Hello YouTube, De-bodgery here. Welcome to EV Components Review, except for that this is not an EV component review at all. In fact, this is a Macbook A2141 repair video. I don't just do EV components. Shocker, I know. I don't. I have been doing electronics repair since the 1970s, the late 1970s. And so this is the current thing that's on my bench. I have two MacBook A2141s in my possession, and they both have the exact same problem. And I will readily admit that I have never done this repair in my life ever. And that's fine. I don't have a problem with that. There's a lot of things I've never ever done before, and I succeed at them anyway. So the fact that I've never wound an in-runner before until the TP128 doesn't suddenly make me a dumbass that can't rewind a motor. Hardly. And here is something else that I've never done before, and I'm literally showing you the process that I'm going through. So this is the inside of one of those two A2141 MacBooks. And so you can see the batteries down here. Here's one of the speakers. Here's one of the other speakers. Bunch of little connectors, one of the two exhaust fans, so on and so forth. Here's the battery connector right there. And obviously the motherboard, which would normally sit right here, is now out. There's a little radiator that sits here and here. These fans force air through them. The air is drawn in through these little side vents on either side and pulled in and then blown out through those. So that's pretty much everything to see here. The bottom cover is held on by 6 pentalobe screws. So you need the special bits to take those out. All right, so next picture is the actual board. And that is right here. So here is the logic board that you would see facing out when you took the bottom cover off. And as you can see, it is riddled with connectors everywhere. You know, like right up here in this corner, right there, you've got 1, 2, 3, 4 connectors and 1, 2, 3, 4, 5, 6 screws, of which they're all different sizes. Well, actually, that's not true. These ones right here are all the same size. That's a different size. That's a different size. So you got literally 3 different size screws and a whole bunch of connectors just in that one little corner of the board right there. And this board is just literally riddled with connectors on it and different size screws. So when you see these little bags in the background here, this is different brackets that hold stuff down. This is different screw sizes, all for different areas of this board. Because otherwise this stuff gets all mixed together. You lose track of what is what. So just keeping these little Ziploc bags full of the right parts in them, that go together, saves me a lot of hassle factor. Right there, you can see one of the little radiators. Here's the other one right there. And this is a heat pipe. It has water inside it. And otherwise, it's a hollow piece of copper pipe that's flattened. Anyway, the water turns to steam. It's wicked out to the cool areas, which is basically the radiators taking heat with it. So it makes a more efficient heat transfer device than just copper does by itself. But the 2 exhaust fans sit here and here. All right, so the actual repair here, there's 2 of them. I caused one of them and the other one I didn't. So right here, this is the T2 security chip underneath that black piece of tape. And that little part right there, that is the flash ROM for it. So it's got the firmware for the T2 chip. It's got the security information in it. It's got the, passwords, whatever else in there. So Apple, in their tremendous wisdom, or rather, proprietariness, they have made this hard to fix. So you literally have to unsolder that little 3mm by 4mm chip, reprogram it, solder it back in place again, and then you get your laptop back. If you ever have this problem, and this is a known problem with MacBooks, that this will happen, that little chip will get corrupted, and you have to do exactly what I'm going to show you have to do in order to get that back again. It's not ideal. It's Apple's way of doing everything, make it hard as possible. They could have done this so many other ways that were less difficult, but they chose this one. Anyway, I have to unsolder that little part. So let's look at the next picture here. and getting in a little closer. So again, here is the T2 chip, and here is its little flash ROM chip. And again, that's 3 millimeters there, 4 millimeters there. You can see some resistors and capacitors around it. So like these little parts right here, they are about 0.5 millimeters long and about 0.25 millimeters wide. They are very, very small. And as you can see, they are right up next to this chip, which is not exactly large itself. And you can also see all these little circuit traces that go to all that stuff and go up underneath this chip. So the circuit traces are, I don't know, 0.15, 0.1 millimeters wide. They're very, 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 very narrow and very fragile. So you can't just manhandle this part. You have to heat it up enough to get the solder underneath it molten, so then you can lift it off without damaging anything. And well, that's a skill set that most people, I would say, I don't know, 99.99999% of the world lack. So yeah, in order to be able to do this kind of work, you need the right tools, you need the right skill set, you need to be very patient and also very careful. So yeah, all of those things are things that most people can't do. All right, let's look at this a little bit closer. And this picture is taken with my Panasonic camera with the macro lens on it. I've brought this up many times in my videos, and here is just another shot of something like that. All right, so, yep, where's that one? Here we go. So here we are even closer in. The camera lens right now is about a 1/2 inch away from this component. So we're in very, very close, and as a result, anything else is kind of out of focus, and being that I'm doing this at an angle, yeah, this stuff over here is quickly out of focus. Really what I was trying to show you was this chip. And again, you can see these traces are very, very fine. You know, the width of a hair kind of a thing. They're very tiny. You know, baby hair, not adult hair for the most part. But yeah, this chip is 3 millimeters this way and 4 millimeters that way. It's very, very small. And this is it before I pulled it up, you know, just taking pictures of the bare board with that chip in place. And now I have removed it. So in order to get it to here, so here is my hot plate surface. I'm heat soaking the board up to about 300, 340 degrees Fahrenheit. And then I apply hot air directly to the component to heat it up enough to turn its solder molten and remove it. In the process of gently tugging on it, the plastic gets very, very soft. And my tweezers skittered across the surface and scratched it up. So these are not deep grooves or anything. They're just surface scratches, but nevertheless, there they are. But there's the flash ROM chip pulled up. You can see back here in the blurry background all the flux and extra solder around it in order to remove it. But yeah, that all gets cleaned up and with alcohol, and everything starts looking nice again after a while. But yeah, I didn't pull up any traces. Everything came up like it should. This is no trivial thing to do that. There's a lot of people that do this and don't think much of it. And I would have to say it's not particularly difficult if you have the right skill set and the right tools to do it. But, well, that's not most people. And that's certainly not anybody at KO Moto because, well, they think I'm an idiot. And I guarantee you they cannot do even that. All right, so next picture is... All right, so this is what I see through my Nikon SMZ 645 microscope. And this photo is taken with my camera on my phone. It's a 48 megapixel camera. And I have a 3-axis mount that I can put on one of the eyepieces so I can take video or photographs like this. And so here is the chip. And as you can see, that is a scratch across the surface. It's not really hurting anything. Here's the other one. You know, so it's completely on the surface, but yeah, I did scratch up the chip. And I'm more than willing to show you that because it's not that important. And I'd rather be transparent and show you how I screwed it up than just like try to blow smoke out my ass and tell you, look how wonderful I am. So yeah, here you go. There's the chip pulled up. Yeah, that's fresh right after I had the thing in that previous picture. Okay, so I think I washed it maybe. Yeah, I did wash it with alcohol to get to this point because it was pretty messed up with flux at that point. All right, so next picture is the bottom side. So here is all the solder pads on here. And these solder pads from here to here are about 0.5 millimeters, and from here to here is about 0.25 millimeters. So these 10 solder pads are very, very small. Very, very small. And again, this picture is taken through one of the eyepieces of my SMZ 645 with my camera on its 3-axis mount for the eyepiece. I have since made a shroud that I machined out of acrylic for this very setup so that I don't get these camera flares. This is external light leaking in, so that's what those spots are. Anyway, that is now machined, and I believe the next picture, or the next one after that, yeah, I got tired of looking at that stuff on camera, so I fixed the problem and used my lathe to machine acrylic to make myself a shroud to stop the light flares from leaking in, because that's just leaked in light. All right, so, yep, grab that one. Okay, so you see I still have them. Yeah, I've got other pictures that are better than this, that no longer have these leaked in lights on here. It's just my overhead lights, bleeding in around the eyepiece. Anyway, so you saw in that last picture, the solder pads were kind of crusty looking and dull. I have now cleaned all that up and added brand new solder on them, so you could call this reballing. You put brand new solder on everything, reflex it all, get them all nice and clean and shiny, so that this chip is now ready to put back in place. And once again, keep in mind, this is 0.5 millimeters long and 0.25 millimeters wide, or about. So extremely small solder pads on the bottom side of this chip. And hey, I did that. I soldered that work, cleaned up all those pads, got this chip ready to be reprogrammed. So that's the next thing, is the chip needs to be reflashed. So yeah, this is a fairly complex process, right? Because there's many steps involved with it. So the next thing is, here is that chip in its little programming socket. Yeah, again, this is an extremely small part. Yeah, and it's in its programming socket. All right, so next picture. And here is the actual programmer I use. So this has an SD card inside it, and it's got a bunch of different Mac BIOSes in it or firmware flashes in it for a bunch of different things. And specifically, this little programmable or plug-in module is for this little T2 flash ROM chip for 2018 to 2020 MacBooks. So that's what's plugged in right now. If I turn this thing on, I can go through its menus and I can find the A2141 and program this chip, which I have done. So anyway, this is what I use, this UFix UBOS 2. You can buy these things on eBay. I probably could find it on Amazon. You can find them on AliExpress. It's a fairly easily found part. That's just the programmer. Nothing really particularly special about it, other than that it is a very specialized tool that you pretty much use only for this job. And they're not cheap either. They're like $350 a piece. So yeah, not something that the average person is going to buy for no reason whatsoever. I did because, well, I've got two A2141 MacBooks, both with the exact same problem. Basically, the programming in here is corrupt. So I've got to reflash it back to factory defaults, and then it all should work. Probably what will happen is once that's done, probably there'll be a notification once I reload the laptop again, because, right now it doesn't work. The OS is corrupt amongst other things, at least on this one it is. Probably after that I'll get a notification that, this is out of date and, Apple will want to re-update it. Hopefully they don't corrupt it again, because I literally just reprogrammed it. But yeah. Anyway, it reflashed just fine. This came up and, it erased it, it reflashed it, checked it, and said it was all done. So I know for a fact that the chip still works. Okay, so then after that, then you have to solder it back in place again. So here it is. soldered back down again exactly as it was before, nice and square in the exact same position as before. I've cleaned this up with alcohol, and then I was dabbing up the liquid alcohol with a cloth, and so I left a couple little strands on there, but I'll wash this board again with more alcohol just to clean it up all the rest of the way. But anyway, yeah, there's the chip back in place. Notice the resistors and these small capacitors and things are undamaged. They're all still there. So yeah, I challenge literally 99.9999% of the world to solder that part back in place yourself. Go ahead. Love to see you do what I can do. Yeah, that's not an easy task. That's not trivial. The people that do this kind of stuff, we don't think it's all that difficult. But the rest of the world, yeah, good luck. Yeah, this is fairly complex things, and I am annoyed that I scratched the chip. But there it is. I did. So what? It's undamaged, it works, it's back in place. Okay, so there is another problem with this board, and I have to fix that one yet, and I'm going to talk about that one next. So, wherever it is, there we go. So again, this is taken with my Panasonic camera with the macro lens. You can see an antenna connector here and here. Once again, I'm about ½ an inch away from the circuit board. These two popped up nice and easy. And I used the same amount of force on this one, and instead it ripped the connector off the board. I was shocked and astonished that that happened. Yeah, the connector, like this one here, is still in the antenna connector. I have yet to get that out. But right here, this is ground, and this is ground. And so those two there, the solder just released, and this one here, it tore up the actual pad. This is an easy one to fix. I'm not worried about that one. This over here, that is more problematic, and I'll show that in the next picture. So this is done again with my Nikon SMZ 645 microscope and my cell phone camera to get this picture. But yeah, this next one here shows more specifically the problem. Okay, so anyway, yeah, you can see this pad was completely lifted off. The solder tore, or the copper tore away. This is a trivial thing to fix. I'm not worried about that one at all. Fixing these is also pretty easy to do. I just got to resolder the actual another connector, which I have plenty of those, down again, and that problem is fixed. It's this one that's the problem. So you can see the little circle right there, and that was the via that was there, and then there was a about a 0.3 by 0.3 millimeter pad right here. Solder pad over top of that thing, and all that stuff pulled up with the connector when the antenna wire did not release like it should have. Right there, you can see a little tiny bit of the trace, and it is very, very tiny. I literally don't have a tool small enough to pull this circuit board area away. This is a multi-layer circuit board, so I can get at that trace. And I also don't trust that this is going to be very reliable anyway. So I'm not going to repair it that way. This is extremely carefuling type work, and I don't trust that my repair of the thing, pulling this away, would be reliable. So anyway, I'm going to repair it a different way, but yeah, that's just completely gone, not to be repaired this way. This is a multi-layer circuit board. I don't know, 8 layers, 10 layers, 12 layers. I don't know how many are in the board, but yeah, it was literally on the next layer down. And it runs back through, so you can see the circuit trace right underneath the surface there, the little kind of slight reddish brownish line right there. That's the signal line that came out right to here for whatever that antenna connector was. Okay, so now you can see what the problem is. The rest of this stuff is pretty easy. This is the hard part. And I would say that this is probably harder to fix than is reflashing the T2 flash ROM and reinstalling it on the board. I'd say this is probably a little bit harder. So next picture is this. Okay, so again, you're looking through the eyepiece of my microscope on my cell phone camera, and you can see this is the area that got torn up, and you can see the other two connectors. I'm not worried about the fact that I got solder in them. I guess if I really cared, I would have put hot air on them and pulled them up first. But these connectors are extremely inexpensive, and I have plenty more of them, so I will do that anyway. So I didn't care that I got them messed up. with solder. So what I had to do was there was a metal shroud on here, and you might have seen that in the previous picture. And I had to get that metal shroud up because I wanted access to these 3 sets of components in here. The solder on here, again, it's real high temperature stuff. It doesn't want to melt very easily. So I applied more solder, lead tin solder on here, which has a much lower melting point, and accidentally got some in those. Yeah, that way I could then release all these little solder pads without destroying anything and get that little metal shroud off of these components. So I'm just going to guess because I don't really know which one is which. So let's pretend like that's the 5.8 gigahertz Wi-Fi antenna, and here is this little transmitter receiver section. And so let's pretend that's the 2.4 Wi-Fi, and here's this little transceiver receiver section, and let's pretend like that one's Bluetooth. And so here is that. You will notice a pattern here. So ignore the solder, but right there, that center pin, that comes out to this leg right here, and you can notice it's got like those 2 notches in it. And this one here is a little blurrier, but it's got those 2 notches on it. And this one, when it was soldered down, it had 2 notches right there as well. So all I need to do is ohm out from here to that solder pad or that solder pad, and I don't know which one it is, but one of those 2 literally connects right to there. And this one here goes to one of those 2 solder pads. And this one right here goes to one of those 2 solder pads. So once I figure it out from these 2, which ones that goes to, now I can run a wire from whichever one of those 2 solder pads right across here to here. So when I solder down the new antenna connector onto here, I can literally run a little wire from here to here. And I will then restore that RF signal, whichever one that was. So that's how I'm going to fix this problem. The little shroud that goes over top of here, I will cut a little slot, probably completely remove this right here. It's not really going to hurt much. So that I have a place for that little wire to run through without getting pinched underneath anything. But that's how I'm going to fix that problem. And that's going to be a fairly trivial thing. The distance from here to here is about 6 millimeters. It's not very long. It's a really, really tiny stretch, maybe 8 millimeters. And again, you're looking at little tiny components here. These are 0.5 millimeters across, or I'm sorry, long, and 0.25 millimeters across. Very, very tiny components on this board. So yeah, a wire from here to here is going to fix this little issue with that pulled up connector, and that'll bring that back to life again. Anyway, still have to work on that one. Just thought I'd show you some of the other stuff that I do when I'm not doing EV component reviews. The only way you can do this kind of stuff is that you're not just some idiot. You have to be fairly intelligent. Your skill set has to be fairly high and fairly specialized to be able to do this kind of work. So yeah, whenever KO Moto people say what they say, that I'm just some dumbass, I don't know what I'm talking about, I challenge all of you KO Moto people to do work like this, because you can't. Because, well, truth of the matter is, you lack the skills. You simply don't have the ability, you don't have the tools to do this. So feel free to keep slamming my name. You literally don't know what the hell you're talking about. So yeah, anyway, got that problem to fix yet, but that's still a fairly trivial thing in my opinion to do. Yeah. Anyway, thought I'd show you guys some of the other stuff that I do when I'm not doing EV component teardowns and reviews. Anyway, take care, folks. Hope that helps. Talk to you later.